So what we're going to do is we're going to look and find out when will a precipitate form or when will it not form. So the next topic we're going to look at is criteria for precipitation. And it's very similar to some of the concepts that we look at in chapters 15 and 16. And the big thing that we're going to look at is Q versus K. And in this particular instance, since we're dealing with solubility equilibria, we're going to compare the Q to the KSP. Now remember, a KSP is a very particular value or a specific value for Q. And the nice thing about this is that Q value, when we're looking at concentrations, we can add pretty much whatever we would like. By the end of the quarter, the cart that's in front of your laboratory station is going to be filled with all kinds of chemicals, and they're going to have all types of different concentrations. So we can manipulate and pick what concentration we would like. And the question is, when we mix them together, will a particular precipitate form? So the Q can be any concentration that we decide to choose. And we're going to manipulate these and vary these throughout our experiments. The K is going to be a specific Q at equilibrium. And we don't have as much flexibility with this because this is an experimentally determined value. And this is going to be different for pretty much every case that we look at. Okay? So if we wanted silver to precipitate out, we're going to have a different concentration if the solution had carbonate in it versus phosphate in it versus sulfate in it. So the thing that we have to do is we have to compare Q and K. If Q is less than the KSP, what we can say is our solution is unsaturated. And the physical result of this is that no precipitate will form. If Q is equal to the KSP, we can say that our solution is saturated. We learned that when we have a saturated solution, this is a specific case that we can say is equilibrium. When our Q is greater than the KSP, we can say that our solution is supersaturated, and as a consequence, the visual evidence of this is going to be that a precipitate forms. The precipitates that we're going to analyze are various colors. They can be, cloudy, not cloudy. You're going to analyze all these reactions that happen in the particular lab. So when you're writing your narrative in your lab notebook, you have to be very specific about what observations that you will observe. So the first question in the first example calculation we're going to look at is, will a precipitate form when I mix two, solutions together? So let's try an example of this. This is going to be a fairly straightforward example. And we can say that if 0.001 molar silver nitrate, which is AgNO3, and 0.003 molar potassium chloride, which is KCl, are mixed, will a precipitate form? So here's the question we want to ask ourselves, and we're going to use an approximation here, and we're going to assume that the concentration of these ions stay the way that they do. Okay? So I'm going to kind of take a step back here, and I want to think about what happens when we mix these two solutions together. Okay? Think back from chapter 4 of our textbook where we talked about solubility rules. And there was a table there, and usually either that table was attached to an exam or you had to memorize that. But we're going to kind of go a little bit farther from this. The first example on that table was all nitrates are soluble. So if we want a particular metal ion in solution, we typically use its nitrate salt and just dissolve it in water, because everything with a nitrate on it is going to be soluble. So in our particular solution down here, if we had a beaker full of this stuff, we're going to have silver ions floating around, and we're also going to have nitrate ions in here. When we mix these two solutions, if we have a potassium chloride solution, the potassium chloride is also soluble. So we're going to have potassium plus ions floating around in solution and Cl minus ions floating around in solution. So at this point, what we can say is that we have silver ions in aqueous solution plus nitrate ions in aqueous solution plus potassium ions in aqueous solution plus chloride ions in aqueous solution. When we add these solutions together, we're going to observe a white precipitate forming. The question is, what precipitate will we observe? If this were a Chemistry 121 class, you would look at the solubility rules, and the product of this particular reaction would be AgCl solid. And you would look and you would say that the potassium and the nitrate are not going to form a precipitate. So we're going to have K plus ions in solution plus NO3 minus ions also in solution. So what happens is whenever a silver and a chloride come together, they're going to form an equilibrium between some solid forming down here at the bottom of the test tube and these ions in solution. This equilibrium is going to be dictated by the KSP. So we have this particular reaction right here. Typically, we can cross out what we would call spectator ions, which occur on both sides of the reaction. And our net ionic equation would be silver plus Cl minus forming AgCl. Now, when we come to Chemistry 123, we're going to take this a little bit farther. And instead of looking at a solubility table to dictate if a precipitate will form or not, we're going to look at a KSP table. If you see a KSP value listed, that's like saying in Chem 121 from Chapter 4 that the product that we look at would be insoluble. So if you see a KSP listed, that means a precipitate is going to form. Think about what you just did last week in lab. You have this calcium iodate, a precipitate forms, right? And there's a KSP value for that. So whenever you see this KSP, that's telling us that, hey, we have a precipitate forming. Okay? So the way we typically set this up now in Chemistry 123 is that we take this solubility expression and we're going to say AgCl solid in equilibrium with Ag plus Cl minus. So here's our equilibrium expression, and we know that the Q is equal to any concentration of silver plus times Cl minus. We also know that the KSP is equal to the concentration of Ag plus at equilibrium times the concentration of Cl minus at equilibrium. These are specific concentrations. And we know that our KSP, if we look at the table for this, is going to be 1.8 times 10 to the minus 10. So the Q that we're looking at, and this expression right here can be any concentration. The problem that we've set up and the concentrations that we used is we're going to say that Q is going to be equal to 0.001 for the silver plus, and it's going to be equal to 0.003 for the Cl minus. And if we calculate this, we get 3 times 10 to the minus 6th for our Q. If we compare the Q versus the KSP, we see that the Q is greater than the KSP. And the conclusion that we can make right here is that a precipitate will form. So this is how we can compare and see whether a precipitate will form. So we pass the saturation point, and we will observe, I believe in this case it's going to be a white precipitate of silver chloride. So this is your more basic example right here, where we mix two solutions together. We say, does a precipitate form, yes or no? One of the things that I want to point out, concentration matters. When we're looking at solutions on our cart up in front of the lab, a 0.5 molar solution is completely different than a 0.05 molar solution. Right? A concentrated solution is completely different from a solution that's not concentrated or has a lower concentration. Okay? So be careful about which solutions you're adding together and what the concentrations are. Okay? Because if you add HCl and you're asked to add 12 molar HCl and you add 1 molar HCl, you're not going to get the same result. So be very careful when you're reading the labels on your various chemicals.